Friends, we would like to learn about perpendicular axis theorem. Now this is very important to understand that the perpendicular axis theorem is applicable for the objects or the bodies which are in the shape of plane lamina. It means planar bodies are going to follow the perpendicular axis theorem. So let me explain you about the perpendicular axis theorem. But mind it, one point is very important, that the perpendicular axis theorem is applicable for plane objects such as plane laminas. Okay, let me show you the diagram. Let's say this is an object and this object has got some thickness here. So it is a plane object, we can say, or it is a plane lamina, because we need to represent three mutually perpendicular axes over here such that two perpendicular axes must be there in this particular plane and one will be perpendicular to the plane. So let me show you the diagram how it looks. So suppose we have got one axis in this direction, let's say in the x direction. Another axis is perpendicular to this, so it is something like this. So let's say this is y direction, this x direction. Both are perpendicular to each other like this. And then the third axis would be perpendicular to this particular plane. So these two axes are in the plane of this body, or we can say in the plane of the lamina. Okay. Third axis is going to be mutually perpendicular to x and y axis, something like this. So let me call this axis as z axis. So perpendicular axis theorem is only valid, only applicable for this kind of body, which is a laminar body, we can say, because these two axes have to be in the plane of the body, right? And third one is going to be perpendicular to the plane. So all these three are mutually perpendicular to each other. This is also 90 degree, we can say, the angle between z and x, and angle between y and z is also 90 degrees, something like this. All these three are mutually perpendicular to each other. So this is a special case of perpendicular axis theorem. If the body is going to rotate about this axis, let's say about x axis, so it is going to have some moment of inertia, that is Ix. So if body is rotating about z axis, so it is going to have some moment of inertia about z axis. And similarly, if body rotates about the y axis, it is going to have some moment of inertia about the y axis. Okay, so these are three individual cases. The rotation about x axis will cause moment of inertia about x axis. Rotation about z axis will cause moment of inertia, that is Iz about z axis, and similarly we'll have moment of inertia of the body about y axis if it rotates about this particular axis. Okay, now we are interested to find out the relationship between these three quantities. So for that, what I will do is I will be taking one small mass, or infinite decimally small mass, we can say, dm at this particular location. Alright, so its perpendicular distance from x axis is going to be this one. Okay, similarly its perpendicular distance, that is perpendicular distance of mass dm about from y axis, is going to be this distance, right? And similarly its perpendicular distance from z axis, if you connect this point, let's say this point is O, so is going to be this distance. Now if I say the coordinate of this mass dm is x, y, z, that is three-dimensional coordinate, friends. So I can say its distance from x axis, that is this distance, so it is parallel to y axis, this is going to be y, friend. Its distance from y axis, it is parallel to x axis, so it is going to be x. And its distance from z axis, let me call this as r. Okay, it is not z because z is going to be in the vertical direction upward. So this is parallel to y, so it is y. This is parallel to x, so it is x. But this distance is straight perpendicular distance from this axis to this. So I'm calling it as r. So it's very simple, friends. Now from geometry, since this is y, this is going to be y, right? So if I apply geometry from here, we can say that this r, because this is 90 degree again, friends, so r square equals to y square plus x square. By geometry, we can write down r square equals x square plus y square. So if you multiply both side by dm and integrate, so multiplying both side by mass, that is small mass dm, that is infinite decimally small mass dm, and integrating, so let's see what we are going to get from here. So we'll be getting from here, friends, this is r square, so it is integration of r square dm equals integration of x square dm plus integration of y square dm, right? Now friends, what is r square, this value? So r square dm is, so mass is dm over here, the distance from this axis, z axis is r, so r square dm integration, it is nothing but the moment of inertia of this lamina or body about z axis. This is nothing but moment of inertia of body about z axis. What about this friends? So this is x, so this is y axis friends. So the perpendicular distance of mass dm from y axis is x. So x square dm is nothing but the moment of inertia of the body about this axis, that is y axis, so we can say it is iy. And similarly, the y is the perpendicular distance of dm, mass dm. So y is the perpendicular distance of mass dm from this x axis, okay. So y square dm and integration, this quantity is going to be moment of inertia of the body with respect to x axis. So we can conclude from here that the moment of inertia about z axis is sum of moment of inertia about x axis and y axis. So this is called as perpendicular axis theorem. So friends, this expression gives us the perpendicular axis theorem. How to interpret this? So the moment of inertia of a plane lamina about an axis perpendicular to its plane equals the sum of the moment of inertia of this body about two mutually perpendicular axes which are lying in the plane of the body, okay. So these two have to be in the plane of the body, that is how we define it, okay. This is called as perpendicular axis theorem. Now by using these theorems, that is parallel axis theorem, perpendicular axis theorem, the next part we shall be deriving the moment of inertia of some known geometrical parts such as rods, disc, rings, etc. Okay. So in the next lecture we shall be deriving the expression of moment of inertia of various objects. Thank you.